कुछ समय अभी से चालू है।
देखो तो
यूट्यूब ऑन की
नहीं, मुझे तो ये ऑन करना पड़ेगा।
यूट्यूब तो कैसे मालूम पड़ेगा कितने लोग हैं?
वही सर पूछ रहे थे
यूट्यूब पे
कि आप लोग कैसे पता करोगे?
और मैप टेस्टिंग कर
You are now unmuted.
हेलो हेलो
लाइक कर
मैं क्या हूँ?
इन कर दो ये सब
ग्रीन सर कैसे कर रहे हैं उनके इसमें
हाँ
सर के
सर
कंप्यूटर पे?
हाँ हेलो
You are now muted.
सब ठीक है।
आवाज आया क्या? यूट्यूब दिख रहा ना अभी?
आवाज से
वहाँ पे चेक कर दो। मैं एक्चुअली ये लाइव स्ट्रीमिंग के वीडियो को लिंक को बंद करना पड़ेगा अपने को।
सर हाँ बंद करेंगे ये रहने दीजिए चालू।
हाँ
इसका ये और इसमें सॉफ्टवेयर में
हेलो 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 चल तो रहा आवाज तो नहीं।
मेरे को नहीं आ रहा है।
तो हम बोलेंगे तब आवाज आएगी ना यहाँ पे। अभी वो कैप्चर का ऑडियो कैप्चर चल तो रहा है। ऑडियो कैप्चर और चल रहा है कुछ।
यहाँ तेज दिख रहे हैं यहाँ पे पूरे नहीं आ रही।
ऑडियो इनपुट कैप्चर है ऑलरेडी। इनपुट और आउटपुट कैप्चर दोनों भी है। ये आवाज आएगी सुनो।
हाँ अरुण
यहाँ से बोलो मैं कुछ।
हेलो चलो हेलो
You are now unmuted.
हेलो हेलो
जाके आ जाओ।
ये जो अभी आवाज जा रही है यहाँ पे आवाज जा रही है वो एक बार देख लो वहाँ पे बज रही है।
आ रहा है ना यूट्यूब पे? आ रहा है ना यूट्यूब पे?
मैं यूट्यूब बंद कर दिया हाँ
You are now muted.
ठीक है देख लेना एक बार तो मैम सेट झालेला आहे
आता सर बोलतील ना
हो आणि अंबर मी पटकन लॉग इन करतो माझ्या कम्प्युटरमधनं. तुम्हाला इथून ना प्रमोट एज मॉडरेटर करत देवेंद्र पालवे. तुम्हाला हो, हे बघ हे असं इथे क्लिक करायचं. समजा अजिंक्य पवार, अखिलेश्वर, अंबर राऊत, इथे प्रमोट टू मॉडरेटर करून टाकायचं मला, म्हणजे मला सगळ्यांना म्यूट करता यायचं. हॅलो सर. अरे हां हो, इकडचं झालं. रंजन जोडतच ऑर्डिन ऑफिस इंटरनेट नाही चालला बघा. पाठवलं सर.
सर तुम्ही करून घ्या ना, मग चालतं परत लगेच.
हां मोबाईलवरनं करू ना.
पर इतना एंड मोमेंट में करते सर, थोड़ा सा पहले जाके उन्होंने करना चाहिए। ये मुझे सर का पसंद नहीं है, बहुत लाइटली लेते हैं सर। मैं थोड़ी सी चेयर क्या करना है, ये प्रोग्राम शुरू होने के बाद यू हैव टू बी पुट एज अ मॉडरेटर।
तो मैं खुद ही कर लेता हूँ, खुद को.
हाँ कर लो ना।
मॉडरेटर
हाँ,
झाला ना.
हाँ.
ठीक आहे. प्रेसिडेंट सर आलेत. सुरू करून घेऊया आता. वो तो सारे नंबर पे
You are now unmuted.
That you are in, right? Karmik sir, good afternoon. Good afternoon. Good afternoon. Good afternoon.
काय म्हणतात
A very good afternoon to one and all. On behalf of Swargya Dadasaheb Phalke Dental College and Hospital and ICT Mumbai, I welcome you all for this online review of Prime Minister Research Fellowship Awarded Research Project on MTA with Professor Dr. Shashank Maske and Dr. Siddesh Mistry. First and foremost, I welcome you all for this presentation during these Corona times on a Sunday afternoon. Thank you all for joining and honoring our request and wishes. Now I would hand over the proceedings to Dr. Mrs. Kulkarni, who will be introducing our speaker. Thank you.
A very good afternoon and warm welcome to all the respected dignitaries, teachers and students. Today's topic is about the MTA, that is mineral trioxide aggregate, which is basically a cement, the cost of which ranges from 3,000 rupees to 5,000 rupees per gram. And our Honorable Chairman Sir, Mr. Sharad Karmek says in humor that it's a cement at the price of gold. MTA was developed for use as a dental root repair material by Mahmoud Torabinejad. MTA is used for creating apical plugs during apexification, repairing root perforations during root canal therapy, and treating internal root resorption. It has many more uses in dentistry. Before we discuss our journey of MOU with the esteemed ICT, I would like to say that it was formerly known as UDCT and is one of the topmost ranked NAC A++ accredited CGPA 3.77 and NIRF ranked topmost university of the country. If I have to talk about the research-oriented work of this highly esteemed institute, it will take a very long time. Such is the stellar performance. The concept of corporate connect with various institutes started with the esteemed ICT and includes a long list of alumni and people associated who are Padma Shri and Padma Vibhushan awardees as the likes of Honorable Respected Padma Vibhushan, Padma Bhushan, Professor Dr. M.M. Sharma Sir, Respected Honorable Padma Vibhushan, Padma Bhushan, Padma Shri, Professor Dr. R.A. Mashelkar Sir, Padma Shri, Professor Dr. G.D. Yadav, and the richest Indian and a global iconic figure, Mr. Mukesh Ambani. Since our esteemed institute is associated with this project, I would like to state humbly that our Honorable Chairman, LMC, Mr. Sharad Karmek Sir, is also an alumni of the esteemed ICT, and we are lucky to be a part of his esteemed organization. He completed his postgraduate studies from this institute, and since the inception of the dental college in 2006, he has been discussing about the MTA and had a very clear vision about it since then. A MOU was signed with the ICT at the hands of Honorable former Vice Chancellor Padma Shri Professor Dr. G.D. Yadav Sir and the then Dean of the Swargya Dadasaheb Karmek Smriti Dental College and Hospital Nagpur, Dr. Sanjay Patil, on June 30, 2017. After signing the MOU, it was taken forward by the Polymer Department of ICT by researchers Dr. Siddesh Mistry and Professor Dr. Shashank Maske Sir. This project is so special for us because not only are we the sponsors with about 3 to 4 million rupees in sponsorship, but the biggest achievement is that this project has recently been awarded the Honorable Prime Minister's Fellowship in February 2020. With great pleasure, I would now like to invite Professor Deshmukh, Registrar ICT, who would like to share his views at the beginning of the session, and then I will invite Professor Dr. Shashank Maske Sir to take over the proceedings. So, Professor Deshmukh Sir, please.
You are now muted.
Good afternoon, everybody. Today we are celebrating 88th birth anniversary of Swargiya Dada Saheb Kalmek, and on this occasion we will have MTA project review. As a registrar of the institute, I take this opportunity to introduce my institute, that is Institute of Chemical Technology, to the audience, which is basically non-ICTN. The Institute of Chemical Technology, Mumbai, is a unique institute which was established on 1st October 1933 as one of the department of the then Bombay University, popularly called as UDCT. ICT has now completed 87 years of glorious past. ICT has created its own brand over the years, which has been recognized by several prestigious awards and accolades to the family ICT, students, alumni individually, and also to the institute. ICT has produced 19 Padma awardees. Under World Bank sponsored project EQUIP Quality Improvement Program, ICT was granted autonomous status in 2004 and deemed to be university deemed to be university on September 12, 2008 by MHRD under section 3 of UGC Act 1956. It was restored and states and of excellence by the government of Maharashtra at par with IITs, ICERs, institutes in the State Assembly on 20th April 2012 by the government of Maharashtra based on its stellar performance on par with all these institutes of national importance. The genesis of ICT Mumbai is truly educative and its achievements are inspirational. It has now three campuses, the main campus at Matunga, Mumbai, and two off campuses at uh, Jalna, Marathwada, and Odisha, Bhubaneswar. ICT Mumbai is running 9 undergraduate programs, 18 postgraduate programs, and 29 PhD programs, one postgraduate diploma in chemical technology management for doctoral students, and one PG certificate course in chemical safety and risk management for all master students of the institute. On 12th February 2018, the University Grant Commission declared this institute as Category 1 deemed to be university status to the ICT, which has maintained high academic standards. NAC has awarded A++ grade with 3.77 CGPA out of 4, which is the highest in the country. ICT was ranked 12th among all engineering institutes, including all IITs, and 15th among Indian universities. It has it is also placed at rank 4 among all pharmacy institutes. ICT is ranked 27th among all institutes and universities in India in BRICS QS ranking, university ranking 2019. ICT was placed 115th position with 100 out of 100 scoring in research. Recently, in ARIA ranking, Atal Renovation ranking, ICT was placed number 1 in India. The role of industry in promoting education and research at ICT has its root in its foundation. From day one of the inception of this institute, ICT started research activities and PhD program. ICT has so far produced more than 500 first generation entrepreneurs. ICT is not just a chemical technology institute, but also covers all branches of chemical sciences, biological sciences, product engineering, material sciences, energy, water treatment, so on and so forth. So I am sure by now you have realized as to why the ICT is held in high esteem and its uniqueness in and heritage among all institutes of higher education learning in India. Great institutes are not built overnight. Tremendous efforts by the stakeholders leads to achievement of the institutes. The rich, the poor, the marginal, the privileged, the underprivileged all studied here and they made ICT big. I am thankful to Sri Sharad Kalmed, who happens to be UDCTN, for sponsoring MTA project to the alma mater. He is our distinguished and proud alumni. Basically, he is a chemical engineer and made his career other than chemical engineering area. Thank you, Shri Sharad Kalmed, for providing me an opportunity to interact with the audience. Thank you all. Now, I will hand over to Professor S.T. Maske to give review on the development of MTA project. Thank you very
You are
much
now
for hearing
unmuted.
me.
I would take this opportunity, Professor Deshmukh sir, to thank you for enlightening us. And we are so proud to be associated with such a fantastic institute that is ICT. I will now take this opportunity to introduce Professor Dr. Shashank Maske sir. He has more than 150 publications, incredible citations, and more than 6 patents to his credit. His research interests include novel approaches for synthesis of nanoparticles, recycling and recovery of polymers, cellulose-based nanoparticles and whiskers, bio-nanocomposites, conductive coatings, rheology of polymers, sol gel techniques, WPUD synthesis, smart polymer and coating synthesis, mineral trioxide aggregate synthesis in dentistry. So I welcome you, sir, and you can take on the proceedings now.
Thank you, madam. Thank you. Thank you.
You are now muted.
And good afternoon to you all. Now, the floor is with me to give the review onto the project which has been sponsored by your organization. The main mind behind this is nothing but your own chairman, Shri Sharad Kalme. He happened to be our ICT or UDCT alumni, and he is the person with whom I have discussed it on MTA, yes, for sure. But other than MTA, also, he has a great affectionation towards our organization. And he himself is also feeling proud to be of the part of this institute, like what I have been thinking on. So, and the great proud to be shared with you here is like I am also from Vidarbha, from Amaravati, which is very near to the Nagpur, and me and Mr. Kalmek is are sharing one geographical location by birth, but as an alma mater or as an organization, yes, we both are UDCTN. So we discussed it on to like he has showed uh, the zeal and the what the intention towards like developing some material into a dentistry to then our Vice Chancellor Professor Yadav as well as to our Guru Professor Sharma, and he came up with his own thinking onto an MTA might be one of the material which ICT can be a part of it. So that topic we churned it at the Vice Chancellor's office with me, then Kalmek sir, then Yadav sir and Professor Sharma on some discussions, and then it reached to the conclusion that we'll develop it this for not only to do something in the dentistry, but his zeal is to like we can do something like the import replacement to the material, and now the term has come. Karnik sir, that time you was been talking about MTA replacement from import, but now government of India is talking about Atmanirbhar Bharat, but we have started Atmanirbhar Bharat much back before the terminology come, because this is one of the great imports in the country in dentistry field. So with this background, let me take to and my uh, to a presentation which I'll share with you, and then we'll discuss it onto the technicality of the matter.
Get your laptop here.
Yes, ನಾನು ಏನು ಅನೌನ್ಸ್ ಬರ್ತೀನಿ. Yes, sir.
क्या हुआ?
एक मिनट.
From where? Yes, thank you. Thank you for providing me now.
Please get your laptop here only and use it. काय झालं त्यांना माहिती.
केलं ना त्यांना.
Should I ask him? Should I ask?
You are now unmuted.
Sir, are you comfortable now?
I am comfortable. I have started loading my presentation, showed me up to 60% loaded.
Yes.
Okay,
I'm
sir.
just waiting to get the PPT.
Okay, sir. Okay, sir. Thank you.
You are now muted.
Could you able to see the slides now?
You are now unmuted.
Yes, sir.
Good going. So, yes, let us start with our Rural Traps and Aggregate project review, which is a second review of the project. Me, with my research student Siddesh, we have been working on to this project, and we have expressed our first
You
review
are now muted.
where the output in terms of the work which we have done it in
You are
the
now unmuted.
that particular tenure was been the activity one. The we all know the overall objective is important to get it an MTA as an the material to be developed here.
You are now muted.
So in activity one we have done it like the reverse engineering of the material of MTA, in which the compositional wise, there are the three main constitution in the material. One is called as an Portland cement, another is the bismuth oxide, and there are certain other additives. So it is an admixture of these three, and then you happen to be call it this material as an one of the material which goes into a dentistry, nothing but an mineral trioxide aggregate. It is an inorganic mass. So we have done the reverse engineering, we have done the literature survey, and we come to the conclusion that the material is made out of this composition. We have an exact composition of this material too, but like the largely it is nothing but the Portland cement, bismuth oxide, and other additives. Then during that review, the select to develop this material, there are the three routes by which you can do so. So selection of synthesis of material can be of one is called as by formulation method, another is a mixing and calcination technique, and third one is the sol gel process. Out of which formulation is nothing but an admixture. The different compositions of this material to be mixed together in physical format and form a MTA. It is also one of the root of development of MTA. The second one is like mixing and calcination of raw material. Calcination is nothing but an elevated temperature conditioning of any material is called as an annealing or a calcination. Calcination, if you do it for a material, that time the packing density of the material gets developed and the overall morphology is intact. So that is the second way of doing it for developing the MTA. And the third one is nothing but the soul gel method. So we adopted a method which is nothing but a soul gel method. Formulation method, you don't have it and too much of customization with you. You can only vary the composition of the product, mix together and give the MTA. Second one was mixing and calcination, where the great amount of energy has to be incorporated to go for a calcination, because this is as elevated temperature process for the longer period of time. And as that's why the same narratives here is like what I've said. Me, your chairman, and our then vice chancellor, when we discussed upon, our aim was not to only develop the MTA. MTA development um, is the one part, lower cost than that of the import of MTA is the right choice of developing the MTA. So on that basis, we churned out to be all data and then come to the conclusion we can save it on to and the process cost as well as the customization of the material at our end better with the synthesis technique. It is nothing but the soul and gel technique. Soul and gel technique is nothing but the solution and form it as a solution and then convert it into a gel, and then gel will get it convert into a solids. This is the method by which we have developed the MTA. So this first review, we could able to reach to a conclusion saying that soil gel can be used. What we have done it in a soil gel, we have done it an hydrolysis of a polymer and utilizing two different nitrates. So nitrate 1 and nitrate 2, and wherever there is a blue dotted line, showed it onto this PPT, we have done it and different batches or optimization. In that case, the polymer hydrolysis, we have done it with the three different way, which is DI water plus alcohol, DI water plus acid. So these three different ingredients we have used for the hydrolysis, that to be with different molar ratio, different pH and different temperature. So as we have done it with this, the hydrolysis plus nitrate 1, nitrate 2, then we were stirring at elevated temperature. Stirring at the elevated temperature is also reached to the conclusion that we have done it at polycondensation and then gelling. In polycondensation and gelling, we have varied the temperature and the time. So if you see it, like there are many permutation and combination while doing it as soil gel method. The produced material then put it into a drying, and then after a drying, for getting it a better geometry of material as far as the packing density is concerned, it's a calcination. So this was the first review on which we have discussed the part of soil gel technique used for MTA. Then the setting time, that time when we reached to was 35 minutes. So the once you have taken the material at this end, then if you want to cure it with the water or with any solution, in that case the setting time was 35 minutes. So this was the first review. Now we come to today's agenda is activity 2, to obtain a similar material as that of biodentine. So that time we have do an reverse engineering of MTA material available and done the whole research activity onto development of this. Whereas now we have something which is called as the benchmark material while development was biodentin. So we have done it as a biodentin reverse engineering. We have utilized our literature survey by using our great library which has been there in the institute with all sorts of literature available in virtual mode as well as into the practical or physical book format. So literature survey, extensive literature survey rather is the right way of putting it here. So because there is in chemical engineering and technology, MTA for us is one of the material. You have been using it into dentistry is one of the applications. For us, we as a chemical engineer and technologist, we are developing one inorganic material. That material, we have done it an extensive literature survey, then XRD, which is X-ray diffractions to know the crystallinity and composition of the material, and scanning electron microscopy with IDAX. So for knowing it, an elemental analysis, particle size and particle structure. All these analysis techniques, all these parameters we have done it in ICT. ICT have all sort of characterization tool available. So we have used XRD, same, IDEX, and then reached to the conclusion saying these are the material with biodentin. And now I am talking about biodentin as a benchmark. We have calcium, then you have silicates, then you have aluminates, then iron and zirconia. So it consists of tricalcium silicates, dicalcium silicate, calcium carbonates, iron oxide and zirconium oxide, and its exact composition will reveal it at the final submission of the report, but we have the exact composition of biodentin material. So the first activity was after reaching a biodentin plus to do the reverse engineering and to get to know what this material is made out of. So this material is made out of one silicates, carbonates and oxides. And that to be the exact composition we have identified. So the first part which we have done it was a biodentin this way. But again I'm just giving you an same input here. Our aim was not to only develop the MTA. MTA with the lowering cost is our agenda. So when we tied a knot with your organization with MOU, Memorandum of Understanding, is not only with MTA development. Your chairman has insisted on lower cost than that of available material of MTA. So whole emphasis was and always there in mind and Siddesh mind is what Mr. Karve has said is like the cost has to be the half than that of the available cost. So the whole crux of this project is revolving around the lowering the cost for development of MTA. MTA development itself is somebody has taught it from the medical or dentistry background was a great thinking process, and then that to be lower in cost is the major crux of this. So we have been doing on that. So though the composition we have received from the biodentin, the exact formulation we know about and biodentin, but only to duplicate it and deliver it to you is not the aim of ICT. ICT's aim is to develop the material which might be a same or superior than that of biodentin, but cost will be lower than that of the biodentin in significant way. So we started synthesizing this material because the admixtures just that's why I'm saying no, MTA development is not our role, otherwise we would have done it. We have bought it an inorganic material, mixed it in our laboratory and given it to you for the trial. It would have been a very easy job for me and Siddesh, but that was not the case. We want to reduce it onto the cost, so we have synthesized that material. First one by sol gel method, which we have already explained to you in the last review. Now, the second one, which we have now been doing it, it is nothing but a Piccini process, which we have utilized to develop the MTA of the similar quality, or might be what I can say here now, because we have the certain analysis with us, better than that of the biodentin, which we have done it, is nothing but a Piccini process. What exactly the Piccini process is? The Piccini process is nothing but a certain acids. Then you take it, I mean, you have the metal ion, and then the metal ion is surrounded to an acid group using this as a chelating agent, and then grabbing that metal ion with the acid part, and then this acid part get it again modified to convert into an ester. So we have ultimately developed a polyester type of material. And let me assure you, it is something which is very novel and unique in this case of MTA. We as a researcher are enjoying this project like anything. And we also currently working with 7 different organizations for development. But this is something which I am really enjoying because here, me and Siddesh too, having and food for a thought all the time during development activities. Because there is no straight route of doing it this. There is no saying that you add A plus B becomes C. This MTA, I am thankful to you and your president in saying that you people have really given a great input to our thinking process in materials technology. So, what materials technology we have been using it is related to the development of polymers, coatings, and rubbers and elastomers and all that way. Well, then this is something which is out of the box for us as well too. But we, I'm really telling you, Kalmik sir, we have been enjoying and our enrichment into an inorganic chemistry based material are really been utilized into this case, which we were not been using day and day out in our department of polymer and coatings. So this is the process, this process findings and development is something which is very unique, by which you will get it and a targeted material, the exact property which you need it can be achieved by this process. As I have been telling you, the way it is being addition of metal ion with acids and then chelation and all, though it is looks like in that simple to understand at this slides, but it is not that easy to develop a proper chelating agent and then convert into the ester which has the metal inside. So for us, even we are well conversed with the, okay, so this chemistry, so we are using it with Picking process. You all people are getting it, because I am on the slide. I really don't know whether you are getting my sound rightly, slides are been moving rightly or no.
You are now unmuted.
So the slides are not moving.
Slides are not moving. You are on which slide now?
So the
You see which slide?
first slide, MTA review 2.
Oh, that's it. How come I am on to and then fourth or fifth slide? Now you would able to see the change.
So it will take some time.
Okay. Would you able to get the slide now, which is synthesis of tri and dry calcium silicate?
Not yet, sir.
So you are still on to the first slide?
Yes, sir.
Okay. So what might be the way to reload it or something like if it is not been there at this? Or should I proceed with the
Yeah,
slides?
you can proceed because it is very well being communicated.
Okay, okay. Thank you.
Yeah.
Okay. So I'm sorry I could not take you around on to my PPT, though I've shared on your portal. But anyway, the it will be any it's a recorded one, so slowly you may be get it into an your chronological way. So schematically representation of the Picini process is nothing but uh, a metal precursor, a acid to form a solution, then added a crosslinker to form a sol, and then convert into a wet gel, and that gel get dried up. So it is nothing but a sol or solution formation of metal precursor with the acid, then converting into a jelly or the gel format, and the gel you evaporate the medium into it and form the dried material, which is a material which is MTA synthesized from Picini process. The basic root of this is nothing but the solvent based chemistry. So what we have been doing it, we are taking a metal ion at the center, acid surrounded by it, and this acid surrounded system will be getting cross-linked. So you are basically getting it a 3D network structure where the metal is at the center. So that becomes your Picini process development using the basic part of sol gel based chemistry. So selection of a raw material, we have the metal precursors, we have nitrate 1, nitrate 2 and oxides. The detailing of each and every chemical composition we will submit it at the last end where we reach to a proper conclusion saying these are the acids. So this acid 1, 2, 3. Right now we know it which all acids we have been using it. But the material which we will give it to you that time will give the whole bunch of the know-how of that material. So we are taking a acid 1, 2, 3, nitrates 1, 2, and oxides, utilizing a certain cross linkers. So we have cross linker also 1, 2, 3. So you can now understand that the precursors are 3, acids are 3, and cross linkers are 3. So all these 3 ingredients we have utilized with different permutation and combination. So the solution one was, I'm perfectly audible to
Sir,
every one of
sir,
you, but
yes, sir, I would just like to tell you that there is a arrow which changes the slides at the bottom.
okay,
So you can just go to the slide that you are on now. The arrow
okay,
will show the next slide change.
okay. Now I've changed the slide by that button, which is forward arrow. So could you able to see the schematic
Yeah,
representation?
it will load. It will load. You will
It will
also be
load.
able to see it, I think.
I am seeing it in with very regular format and the speed.
Okay.
So I'm okay. Only I don't know about those who could able to see the PPT or not. Okay. So
Yes,
now
sir.
I've changed it to that same
Okay,
the
sir.
menu which you have suggested me for the forward arrow.
Okay, sir.
So I'll look at my slides because I'm perfectly okay
Yes, yes,
communicating
yes.
with
You
you.
are
So
perfectly audible, sir. Yes, sir.
yeah. So stages involved in the process is like the solution 1, solution 2. In that case, the solution 1 and 2 has the acid 1, 2, and 3, cross-linker 1, 2, and 3. Why I'm been telling you, in this case, we have the different permutation and combination of the acids, precursors, and linkers. So rise its concentration from 55% to 65%. In second case, we have varied the cross-link from 35% to 45%, and generally use the concentration of acid and cross-linkers and dug out from the literature. So this whole the whole combination, permutation and combination, we have taken some support from the literatures available, and we have given you the solution 1, solution 2 in that case. Now, the solution 3 is nothing but that the nitrates and the oxide where optimization has been done. So, first is to optimize this material and add the solution 1 and 2 to this. So, this becomes the process. Now, sorry, I'll do it with this provider. Okay. So, ratios of solution 1 to 3, all permutation and combination were tried, and solution 1 and 2 has been tried, and we reached to the conclusion saying that 1 is to 10, 1 is to 15, and 1 is to 25 molar ratio of the acid, nitrogen, and phosphorus to reach to an optimum result where we are getting it, and time to obtain the GL was 2.5 hours. Obtain time to obtain the gel in acid 2 was 2 hours, and time to obtain gel in hours in acid 3 is 3 hours. So we have one batch, which is 1 as to 20 per ratio.
Sir, which slide
So
are
one
you on,
example,
sir? Excuse me, sir. Which
I
slide
am
are you?
I am on important parameter optimized while synthesize.
Okay, sir. Slide number, schematic representation of Pekini process,
Okay, further to that,
selection of raw
next,
materials,
next,
stage involved in the process.
next to that slide, the important parameters optimized while synthesis.
Okay, sir.
Okay,
Yes,
so
sir. Yes,
this
sir.
okay, so this I have showed you here what all sort of permutation and combination we have done it with the acids and the cross linkers. All dotted lines, if you continue the dots and get the composition, so there are so many permutation and combination which we tried in the ICT in our laboratory to reach to the conclusion
When
that
you say next, I will.
1 as to 20, the optimum result is right getting it an acid 1 give the best result in all cases. The acid 1 has given the time of gelling is 2.5 hours, and the rest of the results are perfectly okay with the acid 1. This is one of the combination system. There are many combination system which we have done it. If you have seen it, like acids of 55 we have taken, so cross linker 40, then the acids to 65, then the different optimization. So there are different 1, 2 and 3. These numbers, if you see it around, and their number of batches may be more than that of 100 batches which we have done it over the time to get a right set of combination of 1s to 20.
So when you change
Now
the
I am
slide,
going to
you
an
can tell
important
me.
parameters optimized while synthesis. Could you able
Now
to
unmuted.
So
see
you,
that slide?
so you can tell me when you are shifting to the next slide.
Yeah, I have shifted to the next slide. Can you
Okay,
change
sir. Yes,
to
sir.
next slide?
Yes, sir.
Okay. Now the slide is nothing but an important parameters optimized while synthesis. Right?
Yes, sir.
Okay. So I'm thrilled or
You are
I'm
now
so
muted.
happy to show you here the actual picture of MTA as an product, sir. To your chairman, I could able to show you at exact material which we have synthesized. Any researcher, your president can understand this part as a chemical engineer. A development of a material in a laboratory reach to a conclusion, it is something like a eureka concept in the mind. I mean, you feel so something, I've done it. So yes, Mr. Karmik, I have done it with the MTA, with the help of Siddesh, and we could able to come to a conclusion saying that we can develop the MTA, that to be a right material of the quality with lowering cost. So this is your MTA product after gelation and product after calcination. So after calcination product is into a crucible, and
You are now
Mr.
unmuted.
Kamil must be very happy to the word crucible because now in dentistry I don't know whether you people are aware, but no chemical engineer or technologist can live without any experimentation in crucible. So crucible, which we have done it an annealing, try and dicalcium silicate, we have based material of an MTA, and so on permutation combination of calcination also from 750 degree to 850 degree. We have done it the calcination, and annealing we have done it from 1000 to 1500 degree centigrade. So if you can see it, very high elevated temperature we have worked on it to reach to a product and know it and get it as an MTA as a material. Thank you, Mr. Karmek. I can understand the. I mean, thank you very much for congratulating me, but you are the brain behind this material. So it's a team, and as a ICT culture, you know it. It's always a teamwork. No one in ICT say that it is my work or it is I have done it. It is for the institute, by the institute, for the people. So it is the team in which you are also one of it. But yes, sir, now we have the MTA in hand now with right set of a material, with many combination we have done it, leave it at that how much amount of work we have put up. I am not here to tell you that how much amount of hours we have put up for developing the material. But the ultimate aim is like you should reach to the conclusion saying that the material has been developed. Whether you have done it with the 500 batches or 5000 batches is the researchers inputs, but end is like we reach to a very finest end, which is like the development of
You are
MTA.
now muted.
Ma'am, go to an
You are
next
now
slide,
unmuted.
please.
Yes, sir.
You are now
Now, the
muted.
next slide is tin tridisilicate mixture in there mixed with the bismuth oxide and iron oxide in different ratio. The right hand side, the milling process which you could able to see is nothing but in the ball mill. And this whole set and whole experimentation except the biodentine saying by your president to us, all everything has been done it in our lab in ICT and everything has been available with the ICT. We haven't gone out for any work with any precursor, any material, any parameters, any unit operation. Everything is there in our laboratory in ICT. So I'm very much thankful to my own institute and alma mater too to have such a great infrastructure in the research. So yes, we have done it and ball milling, and we have used it and the bismuth oxide iron oxide, taken it into and certain kinds of material, certain kinds of variation and the trace level. Here is also, if you see it, many a time there are the variations and optimization. So this is Mr. Karnak, this is what we call it in ICT as a process intensification project. Do you agree with me? We are been working on to and development simultaneously the process intensification. So this is a product development with process intensification. So everywhere it is optimization and a variation, and out of this all permutation and combination we reach to a one single batch which is optimized. So it is called in chemical engineering language, it is called as the process intensification. So we have the many processes, many development in the chronology, but at the end one of it is the important to reach to a case has to be do it onto an your experimentation part as well as to your theoretical calculations to it. So we have done it in process intensification to develop for the MTA with experimentation. And the next slide, please. Hello,
Ye-
are you able to hear
Yes,
me
sir.
rightly?
Yes, sir. Yes, sir. Absolutely clear.
So can you go to a next slide, which is
Yes, sir. We
preliminary
have.
characterization?
Yes, sir. We have gone to the next slide.
Very good. So thank you for sharing that, ma'am, too. So this is the FTIR
You are now
curves,
muted.
which is on the left hand side of the screen, XRD and SEM. SEM is a scanning electron microscopy, and these are the picture of your own developed material by Solgel as well as to an Picini process. So, though you all people are from the dentistry side, but you can easily see it, and that's why the categorically Siddesh has pasted this picture to know the visualization of the material. The Solgel methods are aggregates, whereas the Picini process is so fine material. If you see it, the packing density is so nice, so uniform, and in Picini process you will get it a closely packed particles, whereas in Sol gel you have the air pockets or you have the loosely packed particles. So Picini process has given me a satisfaction, and I'm really happy. Yes, at end we have done it with a closely packed and the great morphology developed material by using Picini. And FTI and XRD was being utilized to check its chemical nature, to change the nature of the peaks indicates the bismuth doping. So whether we have done it a proper doping of a bismuth, that we have check it with the FTIR, because this spectra of tri and dry calcium silicate, the upper one, the lower one spectra on FTIR is with the bismuth doped. So you have seen it, there is a change in their curves nature, and that shows you the experimental evidences. We as an all UDCTians always talked about in science and technology with justification. So we have been trained to do that way rather. And now my role is to train my own people, Siddesh and all, to go with that along. But if there is a experimental evidences, then only we call it as an this material is successful. If it is like only looked like by an MTA type, will not be agreeable at the institute level. So we always say that experimental evidences. And as uh, Mr. Karmik's mentor, guide, and teachers, one of you which you have seen it, Professor Sharma, he used to always say that there is nothing in this engineering and technology which is thermodynamically impossible. So he can understand the way thermodynamically impossible means which is not been possible by any means. In engineering, it's called as thermodynamically impossible. And his statement is like nothing in this world in engineering and technology is thermodynamically impossible. You tried it with justification. So with justification, sir, we have the bismuth doped material which is experimented with the results of crystallinity of 30 to 30 20 to 32% and with the closely packed Pickney process based MTA material. Madam, next slide please.
You are now unmuted.
Yes, sir.
Okay. Now this picture, which you people can be excited to see probably, which is a
Microphone
cement
muted.
setting. So, which you all call it as an cement, as an MTA. So, we also settled the material, which is your cement, in the petri dish and obtained a setting time. Now we reach 25 minutes. So the 35 minutes in the activity 1 which we have showed. Now, sir, we had the setting material of bismuth doped material. We are here talking about only bismuth oxide derived or developed MTA, which marketed sample have more than 40 minutes as a setting time. We have developed the material bismuth oxide based, which is nothing but a 25-minute setting time. Till time, we haven't gone to an zirconia. Zirconia, we may come much lower, maybe 10 to 15 minutes as a setting time. So, where your biodentin is currently also having the higher setting time than this. It is nearly 15 to 20 minutes, but it is zirconia based. Here, 25 minutes, which is bismuth oxide based, which is the cheapest material. So we will be having two different grades of MTA, which will be having a change in their cost, having a same property as an cement material in dentistry, but setting times are different and their pricing will be different. So one will be by 25 minutes, which marketed setting material is nearly 36 to 37 minutes. And the another one which is zirconia based, which will be coming up, which will be lower than that of your biodentin setting time. Can you please reach to the next slide?
Yes, sir.
Can you go to the next
Yes,
slide?
sir. Yes, sir.
Okay. Now, what ICT has done it till now is been reflected on this slide. ICT has developed and tested two in-house method for the synthesis of MTA. The thorough optimization studies have been performed with the analysis of key steps to be done carefully. Each optimization study has generated to set the data which will be useful when we go for a large scale production, and it gives the idea about how the parameter to be set for smooth production. Bikini process has showed outstanding results with low utilization of energy and less time, which has further reduced the cost of the product. And the last one, which is a zeal of whole experimentation of ours, is the manufacturing cost of the product on the basis of raw material, considering 30 to 35% of the utility cost, which is on the laboratory scale. If you go for the large scale production, which will become much lesser, but still we are in the range of 1500 to 2000 rupees per gram of a material, which is also bismuth oxide based. So this is something achievement of ICT on MTA project till time. That to be higher size of the prices of the raw material, because we have bought it into a lower quantity, so definitely you will get it not exactly the price which production people used to get. Oh, and then the utility cost or unit operations cost, we have added 30 to 35% of the RM, which is also quite exaggerated in terms of production is concerned. But still, it is in the range of 1500 rupees per gram. So, this is the one submission to you on second overview of the project is like the MTA with bismuth oxide having the price of 1500 to 2000 rupees per gram is developed with all kinds of parameters available. Can I go to a second slide, please?
You are now unmuted.
Yes, sir.
Okay. Now the
You are now muted.
future work is ICT will provide two SDK, SDC, and your organization with two best sample from each of the objective of clinical trials of synthesized MTA in December 2020. So what I promised to you, Mr. Karmek, I am ready with my sample to come to you for your clinical trials. So sample is ready to check it for its final application in clinical trials. So I can give you the two samples in December 2020 with certain quantity which you needed. And the replacement of bismuth oxide by zirconia oxide formulation studies start in January 2021. So zirconia oxide based work which will be starting in the new year come up in January 2020. Functionalization of MTA or UV curing application is the start of January 2021. This subject which you can easily recollect, sir, which we have discussed it, like what I mean, if you can give the context to this topic is like this we have discussed in my office in ICT, like why not sir we come up with the material which will be UV cured. So you showed an interest saying that yes definitely if it comes up with the UV curing and the faster curing which is more a greener approach to be used and a better approach to be used. So we also want to do it and functionalization of MTA for UV curing, which people are not been doing it for the UV curing right now, but we will do it with functionalization of MTA for the UV curing, which also going to start it in the new year come up in 2021. And coordination with SDK, SDC on clinical trial of synthesis in-house MTA with the thorough inputs on the clinical property improvement. And at the last, which is like the scale up for large scale production. So now if the clinical trial given by new doctors and think to be like it is the right set of material, we can think for the scale up of this particular material because we have all sorts of know-how, all calculations, all compositions, process parameters with us, which we can easily deliver it to a large scale application. And at the last, with permission of your president, if it to be agreeable onto the activity, ICTA would like to communicate one international review paper in collaboration with your organization, sir, with study under progress. Very soon, ICT will submit the final draft to you for your approvals or other perusals by which you feel so. So there is the first collaborative research publication comes from ICT to your organization. Both are also affiliated to and say such paper. And if you feel so, we can write it onto this because the ICT's culture is whatever deal with an MTA, not now, even throughout my career, throughout the people those who are there in ICT, we always keep the sponsoring company intact and confidential to them only. So we have the complete loyalty to and our collaborators, and we never utter any other things than that of the collaborator. That's why, as our registrar has informed you, there is a legacy and a grace of this organization working with and hundreds of thousands of industries together, but nobody has clear time limit or there is no blot on ICT saying that this work was been duplicated to some company because your one faculty was been working with me, but then he has given it to other guy also. So no single case in this because we have the great integrity and ethical practices in our research activity. That's why I put it to the approval of your president. Otherwise, it is one of the research collaborative paper which definitely we can publish it from ICT itself, but no as it is a MTA, so it will be always by the approval of your presidential board or your president. Once he says that he has the right selection of the journal, we have already done it. Drafting of the paper, we have already done it. Now only the approval will be needed. So now you can reach to a next slide, madam, where I want to thank you all
You are now
and
unmuted.
mention my email address to you all submission sk.at.ictmumbai.edu.in is an organization or institution email address, and you can also use as an @gmail.com as my email address. So this is for your submission my overall. So thank you for giving me appreciation on work, and I'm really happy as a research activity is to do as an activity. So thank you very much.
Thank you very much, Dr. Shashank Maske sir. What a passionate presentation it was. And it was so informative and insightful. Making MTA available at a low cost will be such a great contribution to dentistry. Thank you very much, sir. Before I
Thank you.
conclude, thank you, sir. Before I conclude, I would like to announce for all the undergraduate, postgraduate students, alumni, and teachers that the process of second edition of the Research Awards is complete and third edition process is also going on. You all are aware that the awards is worth 1,11,001 each and is in the names of the great personalities which I'll be mentioning as follows. The first award is Padma Bhushan, Padma Vibhushan, Padma Shri Professor Dr. R. A. Mashelkar Research Cash Award for the Best Patent in Oral Health Care. The second award is Padma Vibhushan, Padma Bhushan Professor Dr. M. Sharma Research Cash Award for UG students. The third award is Padma Bhushan Dr. R. Ahmed Research Cash Award for Teacher Alumni category. The fourth award is Dr. G.B. Shankwalkar Research Cash Award for PG students. The fifth award is Pierre Fauchard and Padma Shri Professor Dr. G.D. Yadav Cash Award for Best Corporate Connect Research in Oral Health Care. So with this, now I will request Dr. Purva Kale to propose a vote of thanks. So over to you, Dr. Purva Kale.
Thank you so much, ma'am. A very warm afternoon to one and all present here. It's my privilege to propose a
You are
vote
now
of
muted.
thanks on the occasion of the 88th birth anniversary of Swargya Dadasaheb Karme, who has been our leading visionary, and to acknowledge the contribution of the dignitaries gracing this occasion. I, Purva Kale, third year postgraduate student, would like to express my heartfelt gratitude to respected Professor Dr. Shashank Maske sir and also to Dr. Siddesh Mistry sir on behalf of Swargya Dadasaheb Karmik Smriti Dental College and Hospital for enlightening us with your words of wisdom on the progress and advancement of the MTA project, which has been selected for the prestigious Prime Minister's Research Fellowship. Your words of wisdom have enlightened us all and will continue to guide us. Thank you, sir. It is a thing of great honor for the entire institute, and this wouldn't have been possible without the vision and constant encouragement for research by our honorable President, sir. I would also like to thank respected Secretary Sir, Dean Sir, for guiding us with your valuable thoughts. As it is very famously said, a milestone like overnight. The wheels start rolling weeks ago. We have been fortunate enough to be banked by a team of very proactive and dedicated institute, ICT Mumbai, who are very well versed with their job. I am short of words for their involvement and their willingness to take on the completion of the task in spite of their busy schedule. My heartfelt gratitude to the research committee of our college, the IT committee, all the faculty members, PG and UG students, and all the participants attending this program. Thank you.
You are now unmuted.
Thank you, Purva. I would like to tell all the audience that respected Dr. Shashank Maske sir has shared his email, and any questions that you have, you can address to his email. Thank you so much.
Thank you. I just want to express my gesture to your
You are now
organization,
muted.
and specifically I wish to thank Sri Sharad Karmik as an visionary into this project for sure, which I have already been said to you. But one more thing which you people must not be knowing it, which I just want to put it on this open platform here is today the Siddesh Mestri, who is my PhD working with me, his PM fellowship award was was the great input by Mr. Sharad Karnik in person. So, as a president of organization and all, definitely yes, for us, Mr. Sharad Karnik is our alumni, a great and distinguished alumni. We have the right on our alumni, and they have the right on our own faculties and alma maters too. But today, what Siddesh has been drawing at the PM fellowship is just because of he has submitted all sorts of bureaucratic activities which is required by PM office on time, and that to be in an app format. And that's why today we have the Siddesh drawing at the PM fellowship, sir. I'm eternally thankful to you from my personal capacity as an Shashank Musketu to you, to Mr. Sharad Karnik as my alma mater and alumni. I'm really proud to be
The slides are
in touch with one of our great alumni and great support to our current student who will be also happen to be a Siddesh, a proud alumni soon. But thank you very much from me and Siddesh side to you, sir, and your organization, because your organization has put forward that application to CII on time, and then we could able to reach you. So thank you very much, and have a great day ahead, and we'll meet you soon, probably in a month's time, because your awaited visits to Mumbai is long pending. So I want to really want to show you in practical
You are now
presence how that
unmuted.
material is. Thank you very much. Thank you very much.
Thank you, sir. I would like to say that the session is concluded and we had a very great time. So, see you all very soon. So, the session is concluded now, and thank you very much for participating, everyone. Thanks a lot.
You are now muted.